All around me are familiar faces, worn out spaces, worn out faces, going nowhere with their daily races, going nowhere, going nowhere, and I find it kind of funny.
Ready, on.
Okay. Good morning. I am Rishvinder, here live at the scene of the crime. Just 5 hours ago, while you were soundly asleep, a bomb exploded. Yet right here at the very dribbling cafeteria, aka VJC. Now let's get in and investigate more. That you are witness here, so can you tell us more about it? My sentiments exactly. Okay, here we are at the crime scene.
Excuse me, who are you?
Good morning, sir. I am Ruby, dear.
Oh, shut up, you ostrich. Get out of here.
No, wait! Who are you?
Who am I? Oh, you've got to be kidding me. I'm Ken Crime, chief of the police squad.
Hey, sir!
Yes.
I found a trace of ammonium nitrate. It's usually found in a fertilizer. But I know who did it.
Who? Oh. Oh, man, don't tell me. It's him again? Ah, let's go. Come on.
Alright, there you have it. Ammonium nitrate is bomb. But how? Before we find out more about it, let me introduce to you other common bombs. Now, for the bomb section of our sexy news. Here are some common explosives. First up, we have TNT, also known as trinitrotoluene. TNT combusts upon detonation according to the following chemical combustion equations. 2 moles of TNT combust to give 3 moles of nitrogen, 5 moles of oxygen, 7 moles of carbon monoxide, and 7 moles of carbon in the form of soot. This reaction has a high activation energy and is highly ecdothermic. Next, we have ammonium nitrate. Ammonium nitrate is commonly used as fertilizers, but is also used as an explosive. For instance, during the Oklahoma City bombing, it is usually found as mixtures with other hydrocarbon like fuel oil and alcohol. It's an ecdothermic reaction, but it's difficult to detonate. Another explosive or heat is required to detonate.
May I come in, sir?
Yeah, come in. So, did you get him?
Yes. The terrorist is in custody now.
Did you handle him with care?
Yes. He pleaded guilty,
Oh, wait, he pleaded guilty? Then what's the problem?
but he don't explain the bomb.
Why not? You know what, let me have a go at it, alright? I want to interrogate him myself.
Okay, wait. But we need to write the arrest report first.
Arrest report? Alright, I'll do it now. What do I have to explain?
Right, for the arrest report, I'm going to talk about how scenes of explosions are processed and how chemistry is used in examining a scene of an explosion. Some material is commonly collected from a scene of an explosion. Bulk explosives. Samples for traces of explosives. Non-explosive items. And post-explosion debris. The samples collected are then compared against a list of pre-collected samples which form a database. Some examples of techniques involved in the process are high-performance liquid chromatography, also known as HPLC. This is the end of the report. If you have any more questions, please contact me, Chief Ken Crime, or Detective Oxy Chen.
But what? You went out there and you killed hundreds of people, and all you can say is what?
Campbell soup.
Thanks, Oxy, I got it. Listen, what's your name, kid?
I go boom. I go boom.
Look, Mr. Go Boom, I'm gonna ask you once, and once only, and if you don't give me a straight answer, I'm gonna make your life a living hell. You hear me?
Fine. I'll show you my PowerPoint presentation in compatibility mode.
Chemical explosives undergo exothermic reactions to release energy. This energy can be obtained in the form of combustion reactions. Most of the energy released comes from oxidation reactions. The amount of oxygen available there is an important factor on the strength of the reaction. If there isn't enough to react with the carbon and hydrogen, the explosion is considered to be oxygen deficient. The amount of oxygen can be determined through an oxygen balance equation. This is an equation that expresses the degree to which an explosive can be oxidized. The nearer the oxygen balance value is to zero, the stronger, more powerful, and sensitive to reaction. When OB is greater than zero, the molecule contains more oxygen than is needed. When the oxygen balance is smaller than zero, the combustion will be incomplete, and large amount of gases will remain. However, other conditions like volatility, stability, might limit the oxygen balance of a reaction. The conversion of enthalpy of an explosion into mechanical work is dependent on the amount of gases in the product available for expansion. TNT releases 10 moles of gas per mole of explosive. This is the standard for other calculations. Also known as the Berthelot's approximation, relative explosive strength of a material relative to TNT can be determined by considering the change in internal energy and the amount of gas produced. Strong explosives are not just highly energetic, given by Berthelot's approximation. They also react violently. The speed of reaction is vital to the buildup of a large energy density, where that is the large amount of energy per small volume. In reactions that proceed slowly, energy is dissipated to the surroundings. Explosives can be characterized into two broad categories: high explosives and low explosives. High explosives are explosive materials that react very violently. Low explosives are explosive materials that release a lot of energy but undergo a slow reaction. Oxidation reactions and explosive reactions are not spontaneous. There's an energy barrier that must be overcome in order to initiate the reaction. The input of energy required can be mechanical, as in pressure, or could be in the form of heat, for example, a match. The sensitivity is the ease by which the explosives can be detonated. This is a schematic diagram to explain the concept of an explosive train, or the sequence in which a bomb is set off. First, there will be the detonation of a primary explosive. This will provide the energy required to initiate the combustion reaction of the explosive. After the detonation of the primary explosive, there will be a detonation of a base charge, where previous detonation causes the detonation of a slightly larger base charge that acts as a booster and amplifies the effect several-fold. It is only after this that the main charge gets detonated, where a large amount of secondary material is set off. These are some explosive materials commonly used in the functions in the explosive train.
And there you have it. Another job well done by the investigating team. Or was it? The bomb, please.
$1, please.
So, case unsolved. Rubidium